All right, let's dive into something really fascinating today. We're going to explore a pretty radical new idea in AI. What if we could build a mind that doesn't just get smarter, but actually grows wiser? Let's get into it.
So, have you ever noticed that even though today's AIs are unbelievably brilliant at certain things, they still feel kinda stuck? It's like they're the world's greatest concert pianist. They can play Chopin flawlessly. But if you ask them to just pick up a guitar and learn a few chords, they can't. They're completely boxed in. That's the core problem we're talking about.
And this, of course, has a name. Researchers call it the fixed capability problem. It's the big reason why even the most powerful AI models can seem so fragile, so brittle, the second they run into something new.
Basically, these systems are absolute masters of what they've been trained on. But here's the catch. They can't learn what they don't already know. And that brittleness isn't just some minor bug. It's a massive roadblock on the path to creating systems that are truly intelligent and adaptable.
So how do we get around this? Well, the first part of a potential solution is a new architecture called RAVANA. And the really cool thing here is that RAVANA isn't just another giant language model. It's an attempt to build a whole new kind of AI mind, and it's built on ideas from human psychology.
So, instead of just training it to get the right answer, RAVANA is driven by a set of internal pressures. You can think of it like your own conscience or that little nagging voice in your head when your beliefs don't quite line up. It's these internal conflicts that actually force RAVANA to grow, to become more coherent and, well, wise over time, not just more powerful.
And there are 4 of these core pressures pushing it. First, it's designed to hate inconsistency. It actually gets punished for flawed logic, so it's always trying to make more sense. Second, it's built to avoid getting stuck in its own ways. And get this, it uses a wild technique called dream sabotage to actively challenge its own strongest beliefs. Third, it rewards deep, effortful learning, the hard stuff, not just easy wins. And fourth, it has to stay true to itself, constantly checking its actions against its core values to maintain a stable identity.
Okay, so if RAVANA is this wise, self-reflecting teacher, who's the student? That's where the second part of this system comes in. It's called ASURA. RAVANA literally spawns this apprentice AI to go out and learn specific tasks right from scratch.
This whole teacher-apprentice relationship is really the secret sauce. You can think of RAVANA as the operating system for growth. It provides the deep wisdom and the basic tools for thinking. ASURA is the application. It takes those tools and gets its hands dirty in the real world, developing specialized skills through direct experience.
And this is where it gets super clever. Asura's memory isn't just a giant hard drive of facts. No, it's a structured 3-layer system. At the very bottom, you have all the raw, messy, real-world experience. The system then processes that into refined, abstract skills in the middle layer. And then, at the top, it combines those skills into high-level strategies. It's a pipeline that literally turns chaos into capability.
So the big question is, how does ASURA actually do that? How does it go from being a total novice to a master? The answer is a process at its very core called the Capability Genesis Loop. You can think of this as the engine that drives all of its growth.
Whoa, okay, I know what you're thinking. That flowchart looks a little intense. But don't worry, we're not going to go through every single box. The main thing to get is that this is the detailed step-by-step playbook Insuria uses to build a brand new skill from absolutely nothing. And we can really break it down into 5 simple phases that might sound surprisingly familiar.
I mean, this is basically how we humans learn, right? It starts with need detection, that, I don't know how to do this moment. So what do you do next? You go into exploration mode, you research, you experiment. Then comes internalization, where it all finally clicks and you turn what you've learned into a real skill. But you're not done. You have to evaluate it, stress test it, find its limits. And finally, once it's proven reliable, you hit stabilization, and it becomes a permanent part of your toolkit. And this isn't just a cool theory. It actually works. Take a look at this graph. This shows the agent tackling a financial reasoning task. See how it's kind of stuck at the beginning? Then it hits that yellow exploration phase and starts trying new things. And then look at what happens in the green internalization phase. The performance just skyrockets. That's the aha moment. It then levels off as it evaluates and stabilizes that new skill, resulting in a sustained 50% jump in performance. It literally taught itself to be better at its job.
So let's just pull back for a second. What does all this really mean? Well, it suggests we could be on the verge of a huge shift in AI, an era where we're moving away from building brittle code and towards architecting something that looks a lot more like wisdom.
This is a massive paradigm shift. Think about it. We're going from traditional AI, where you have to program in every skill, to an AI that develops skills all on its own. From AI that's brittle to one that adapts. From static capabilities to emergent growth. And maybe most importantly, we're going from a world where safety means bolting on external rules to one where an AI has internalized values and can correct itself. That's a game changer.
The project's conclusion really says it all. The path to AGI is not through larger models or more data, but through deeper understanding of how human minds achieve wisdom, integrity, and adaptability. It suggests that maybe the answer isn't just more data or more computing power. Maybe the key is actually understanding ourselves a little better first.
And now leaves us with a pretty wild final question to think about. If we can actually build an AI that can develop its own wisdom, what will it decide to learn next? And maybe, just maybe, what will it end up teaching us?